Hello and welcome to our talk. We are talking about DR testing for databases and applications. First, as an introduction for DR testing, it's about making sure that our important databases and applications can be recovered quickly and effectively. Why is it important? It's important to prepare so that we minimize our downtime and our data loss. And in my opinion, only a tested DR procedure is valid. Then a little bit of an introduction about us. So we are from Libelle IT Group. We have 30 years of experience in disaster recovery and business continuity. We have 500 plus customers. We have mirrored a lot of data in databases. We have mirrored a lot of files in applications. So we have a lot of experience there. An introduction about me. I'm Daniel Kruger. I'm the team lead of Business Shadow. I'm responsible for the development and for the customer support for our tool Libelle Business Shadow, which can be used to mirror databases and applications. Then about my colleague, Puneet.
Hello everyone, my name is Puneet Khatri and I have 15 years of experience in database administration and SAP basis administration. I have 10 years of experience as DR solution architect. I'm with Libelle since last 10 years and currently serving as services lead for Libelle Americas. I'm handling different customers from a small shop with the size of 50 GB of database size to large scale with 300 plus terabytes of database for disaster recovery, of architecture planning, implementation, and support.
So about the people in disaster recovery, I think they are special because the stakes are so high and peak performance is required. The passing grade is an A. You have to do everything right to make it work. Also, performing under pressure is necessary. And if it works, nobody will know it. If it fails, everybody will know it. And I think the sports analogy fits there. A good offensive wins the game, and a good defense wins the tournament. So now a little bit about disasters.
So disasters are happening everywhere. Something is failing every time. If we talk about the different dates and if you remember the history, some of the examples we have here, like in 1962, there was Mariner 1 space probe a disaster which happened. We also had some automobile industry disaster which happened in 2000s, and then recently in 2024 we had this fiasco from CrowdStrike where all the Windows security patches created a trouble and the complete airline industry was stuck, and which created a lot of problem. Database and applications, why it is important? First of all, the databases and applications, they are actually the foundation of any modern business. Everywhere, if we have the IT infrastructure, the database and applications are there, which runs majority of the business, where all the data is stored, because databases applications, they have the structured way of storing the data and presenting that essential business data to the key stakeholders so that they can make a financial business decisions, and they also have all the previous transaction histories to make such kind of important critical decision to make their business move forward. And those applications are very critical. They are core of the business process. If any of the application which fails, it creates a lot of financial loss as well as different losses in overall industry, and the spectrum of different processes as well fail together. On an average, disasters are happening all the time. We have seen that in the previous slide also, that we have a history of disaster which are happening in the application and databases. Based on the stats, on an average, every 2 years, some disaster happens in a given industry or company. Now, that disaster can be because of the hardware corruption, it can be because of human error. And for human error, I can give you in one scenario which I personally faced when I was working on one of the database, which is a huge database of Oracle, where the size of database itself is 70 to 80 terabyte, where some technical person mistakenly completely just deleted the whole database because that person was having the elevated access. Of course, as a reactive response, that access was reduced, security features was enabled into that. But at that point, the company was not having the right disaster recovery planning, and because of that, they lost around 3 to 4 days worth of business because of that human error which happened. And that's a classic example where we need to have a right solution in place so that if the disaster happened because of human error, we can bring the system up in time with zero downtime. So that's really important. Other errors can be a software errors, application errors, where all the times we have a lot of applications running on the servers which cause sometimes unnecessary and unwanted issues that can cause the disaster as well. Ransomware attacks are happening all over the world, and then now this is increasing everywhere where ransomware is happening. So we should be prepared and planned in order to save our applications and databases. DDoS attacks are happening, and then some of the attacks which are outside the human errors or hardware or software errors are like power outages, which can happen anytime. Natural disasters like floods, earthquakes, that can happen anytime, and that can cause serious disaster issues on the data center wherever it is hosted. Even though if we have cloud setup, those cloud setups are also having a physical data center anywhere, and for that also we have to make sure that we have a right disaster recovery configuration setup also in the cloud, properly set up for that.
So we talked about the different scenarios that can happen, and historically also a lot of disasters have happened in databases and applications. So here there are some historical databases which you probably already know about. So I think for us, some of the more famous ones are, for example, the GitLab database incident, where an intern deleted a production database on one of their first days, and it was a huge problem for GitLab. Or, for example, the Amazon Web Services S3 outage, also where a production database was deleted, which then led to an outage of the AWS storage service S3.
So ransomware attacks are also now, as I mentioned before, these are kind of attacks which are happening quite frequently nowadays, where it is happening. Starting from 2016, we had the ransomware attack in this medical center in Hollywood, and the recent one which happened in 2024, where Quillen ransomware attack caused some major destruction on those companies.
So now we talked about the different disasters that happened. And so we all know how severe disasters can be, and we want to do DR testing. But before we can talk about DR testing, first let's take a look at how not to do DR testing. Chernobyl is probably the worst DR test in history. It's not in software, but still I think many lessons can be learned from that. So originally it was planned to test if it would be possible to have the turbines spin for long enough time until the diesel generators could start up and take over. That was needed to test whether the cooling pumps would then still be operated to have a safe operation of the reactor. They wanted to test it by reducing the reactor's power output to a low level so that they could simulate an electrical power outage. But when they did the test, several things went wrong. At the start of the test, they already had different delays. So originally it was planned to start it at noon, but because of production quotas, they needed still to produce electricity for 10 more hours. And actually they started close before midnight. That had the effect that not the experienced day shift was operating the test, but the inexperienced night shift. Then when they dropped the power, they had unintended effects. Because of the reactor design, it was dropping power faster than they expected. And they had additional effects where then the reactor was almost stalled. And even with these unstable conditions, they decided to proceed with the test. And they got into dangerous territory where they tried to start up the reactor too fast and in an unsafe manner, and where it then led to the destruction of the reactor. So the lessons that we can learn from that is, one, to think about the risks that can happen with such a test. What are the safe ways to perform the test, and what are areas where we could get into danger? Then the next thing is they didn't follow their safety protocols, and that is an important thing to do. Also, they had miscommunication. And like I said earlier, they had the inexperienced night shift that was doing the test, which also caused problems. Also, they were suffering from design flaws and systemic issues where even if they operated perfectly, it was not possible to prevent that disaster. Overall, the first goal of the DR test should always be, let's not create a disaster. So now that we know how not to do the DR testing, now what steps do we need to do? So first, we need to understand the scope. The first step is identifying the critical systems. So we need to check which systems are most important for our operations, which systems contain the most important data, and which systems have the biggest impact on revenue. Then we need to think about what happens if those systems are gone. What impact does it have on revenue? What impact does it have on our data and on our operations? Then there are different databases and applications that we can look at. First, there's the transactional databases. Those are databases that are used for day-to-day operation. They store the data that is needed for our operations for different applications that allow us to do our business processes. Then there are the analytical databases, which are not used in day-to-day operations, but still are important because they allow us to do business intelligence. So we can analyze our operations and we can improve them. Then there are legacy systems, which can be older systems that can still hold critical information, or maybe they could still perform some critical operations. And it could also be important, those legacy systems, because they store data that is needed for compliance or financial reporting. Last, there are the customer-facing applications. They can be web applications or mobile applications that have a direct impact on the customer experience. Then as a next step to identify the critical databases and applications, first we can do an inventory. There we do a catalog of all the databases and applications that we have. Next, we can talk to stakeholders to get information on which systems are important and what impact will it have if those systems are not available. Next, we can do data flow analysis to check how does data flow through our organization and which are the critical nodes. Then we can do risk assessment, writing down different risks and calculating what is the likelihood of that risk and how big is the effect that it would have. Last, we can set recovery objectives for these critical databases and applications. One is the recovery time objective. How fast should this database or application become available in our DR scenario? How fast do we have to make it available? And then the recovery point objective. What is the maximum data loss that is tolerable for that database or application? Then we need to plan our test. So first, we need to define the objectives. So that is then identifying the goals. So the first one is a recovery time objective. How fast should the system become available in a DR scenario? Then there's the recovery point objective, which is then how much data do we lose in a DR scenario? Next is the application functionality. So do the applications function correctly after recovery? Are the critical functions that our users need, are they available? If we have the goals, then we need to think about scope and limitations. So we need to think about which databases, which applications, which components in our network are to be tested. And we also need to think about what is outside of the scope to manage expectations. Then there are different test types that we can do. First is the failover testing. So that is the testing of our manual or automatic failover procedure. Does it work or does it not work? Then there are data restoration testing. That is to test whether our backup methods work. So from our backup, can we restore the data and is it then complete? Next is the application functionality testing to check if the critical functions of the application are working in a DR scenario. Then there's a light DR test scenario where we still leave the production system running and we perform the test on a DR site to check whether the DR site comes online and is available. The biggest DR test that we can do is a full interruption test where we simulate a real DR scenario. We shut down the production system and we test whether the DR site comes online and is accessible and available. This is the most realistic, but also the most dangerous test scenario. Next, we need to define success criteria for our test. First, there are the technical metrics like RTO and RPO, part numbers that can be calculated whether we meet them or not. Then there's the system performance. Is our system fast enough? If it's too slow, it could be as bad as if it's unavailable. Next, there are the operational criteria. So first, there's the functionality. Are the functions available that we need? Then there's the user accessibility. So can our users log in to the application and can they use the functions that they need? Next then is the documenting and reporting the test. So if we run the test, what is the documentation that we need to produce? What are the logs that we need to produce? And at the end of the test, there should be an outcome report where we write down the results of the test and actionable insights that we then need to do. So then about the test plan, first there's the preparation. So we need to define what are the different team roles and responsibilities in the test. Who does what? Then we need to create a test schedule of when will we do the test and what action items are to be done. For the execution, we also need to produce a pre-test checklist. Those are preconditions that need to be met so that we can go ahead with the actual DR test. Next is then the test scenario. What are the DR steps that we will do in the DR test? And then there are the post-test activities where we review the test, we write down the results, and we make adjustments to our DR plan. And after that, there's also the communication. So we need to communicate the results to the different stakeholders. So here are the different teams and responsibilities involved in the DR test. So usually it would be there's a DR manager. That is one person that is responsible for the successful completion of the DR test. They are responsible that the steps are executed within the given time and that they are completed successfully. They are responsible for managing the different teams, that they are available and that they are completing their action items. Then, for example, for testing the application, there can be people from the application team or from the quality assurance team that then do the application testing in a DR test. And there can also be specialists from the database team, from the network team to test those different components or to perform certain actions on those components.
Once we have the right execution plan, once we have the right testing objectives, like what are the success criteria and everything defined, as Daniel mentioned, that the key stakeholders and people, once they are aligned, the next thing is absolutely that we need to make sure that we have a pre-test checklist. And here is an example of pre-test checklist where if we have certain things in place before we actually execute the DR test, it makes things much simpler and smoother when we actually run the test. And these are the certain things which we keep updating based on our DR test feedbacks or DR test learnings. And we add those kind of things as a task so that we don't face such kind of issues again and again when we do DR test activities in future. So some of the examples are we have to make sure that if there is any downtime needed for the test, do we have the right approval for that? Do we have already scheduled everything or not? And in the checklist, we have to make sure that it is completed. This is going to also help you for future audits and documentation purpose also, so that in case there is an audit happening after the DR test, that what are the steps we followed, we have everything listed in the checklist. So this is really important. And if we don't have certain activities which required a certain technical person to assign, for example, permissions here, if the technical person who's performing DR test activity don't have the right permission, at that point we need to reach out to the right stakeholders so that we have the appropriate resources and appropriate authorization to perform the DR test activity. So that's why the checklist is very important and we should follow the checklist whenever we perform the DR test activity. Here, this is a test schedule. Just again, this is an example. It all depends on the customer environment and the availability of the systems. But this is a high level example where it is showing that if we start the activity at 8 o'clock in the checklist, We have to make sure that the pre-test checklist is completely followed, how much time it took, we record that. Similarly, there is a go or no-go decision can happen after that, whether we are ready with the whole complete stakeholders are okay with moving ahead with the activity or not, and we record that time. And similarly, each and every steps what we follow, record the time so that we know how much time this activity took. And in future, if we have to plan further DR test activities, these time durations will help you to plan the activity ahead so that we know that how much downtime is needed for that particular system to perform a DR test activity, because these are the steps which performed last time. And this is also a good reference for future DR test as well, so that each and every key person know when that particular task needs to be performed, because these tasks and these activity might be assigned to different technical persons, and these technical person will get to know based on this schedule when they have to be available and when they have to perform this kind of activity during the DR test.
For test planning, there's also challenges that can come up. So with the team availability, there could be issues that people are unavailable because of different reasons. People take holidays, people become sick, and it might already be a challenge to schedule the test based on the given availability of the different team members. Then there could also be resource allocation issues. So we want to do sufficient DR testing, but we want to have minimum business impact. Then also we want to do a realistic testing, but also a safe test. We don't want to have actual data loss. Now for the DR environment preparation, first we need to understand the production environment. So for that, we need to take an inventory of the components. How does the hardware look like? What hardware components does it have? How does the software stack look like? What different tools are installed there? And how is the network configured? What are the dependencies between the network components? And then also, how is the storage configured? Then there's also, we need to look at how big is the data volume and what is all that complexity that we need to map onto the DR environment. So when creating the DR environment, we have different ways of doing that. So for mirroring the infrastructure, we can use virtual machines or, for example, Docker container to be independent of physical machines. We can also use cloud services, for example, having the DR environment in the cloud. For synchronizing the data between the production system and the DR system, we can use replication tools like our Libelle Business Shadow. And there could also be the necessity for data masking on the DR system to masking certain information to not have attackers access that information. Then we also need to configure the network between the systems. And then we can also use automated tools for configuring the DR environment like Puppet, Ansible, or Chef. That gives us the advantage of having reproducible infrastructure. Then once the DR environment is created, we need to validate it to see that the basic functionality is working and to also see whether from the performance that it's fast enough to meet our requirements. And it might also be necessary to look at the security, that it's secure enough, because it might also be a valuable target for attackers. When preparing the DR environment, there might also be challenges. For example, it's additional cost, additional resources that need to be allocated. It can be a challenge to synchronize the data from the production system to the DR system. And it's also additional complexity creating a DR environment than just having one production system. While producing the DR environment, it's good to document the different steps for other team members and also to do change management so that when, for example, the database is updated on the production system, that it's also updated on the DR system. And also, it's good to isolate the DR environment somewhat from the production system so that we don't have an impact on the production system. Next, about the execution of the DR test. So first, in the execution of the DR test, we go through our pre-test checklist. Like mentioned before, we have to check the team availability, the team readiness. We have to check that our environment is ready. We also have to check that our backups are available and that they are healthy. And we also need to check that our rollback plan is available. Then we run the DR test, we start the test. And while we go through the different steps in the test, we need to monitor. We need to monitor the production system, the DR system, to see how it's behaving, how the performance is, checking the error logs if we see any errors. And also, while we run the steps, we also need to document what step is being done, by whom, when did it start, when did it finish, and that we can also check off those items. If issues occur, we also need to track them. We need to insert them into the issue tracker. Mainly, we do the step-by-step execution. So it could be either that we test our failover mechanism, it could be that we test our backup mechanism, or we do a testing of our application. While testing, we also need to prevent risks. So we need to follow our safety measures and we need to stay inside safe limits. And we also need to have our rollback plan available that if in the middle of the test we see that we can't continue, that we have a way of going back to a healthy production system. That is what the rollback plan is for.
So the planning is very important. Now, running the DR test execution, usually what happened during this time is that when we are running the DR test, there is either the responsible people or the complete team, either they are sitting in one conference room or there is a conference call which is going on, and then there is one coordinator who makes sure that we follow the activity as per plan and as sequential as possible. There can be certain activities which can be done in parallel, but coordinator or project manager for that DR test has to make sure that those things are happening by responsible person, follow up with them and make sure they are completed or not. Once it's completed, that project coordinator or DR test coordinator has to make sure that it is updated in the execution list.
When executing the DR test, there are also challenges that can come up. So first, there can be data integrity issues. So it could be that after switching over, we might see that the data is not complete, or it could be that we have consistency issues with the data. There might also be dependency issues that previously were not known. So it might be that the application cannot start because it's depending on other applications or other components that are not available. There might also be performance impacts. So it could be that in the DR test, we see that when the DR site becomes online, it's actually so slow that it's unusable. During test execution, while doing the steps, we could see that people or tools, it could be that we see that our scripts or our tools or that certain actions are not possible because of permission issues. It might also be that certain actions are not possible because of operating system resource limitations. Then there could also be delays where certain steps take longer than expected or because of unavailability of certain team members. Then there might also be miscommunication that because of miscommunication, the wrong actions are taken. And last, there might also be failures that were completely unexpected. Now, after the DR test has been executed, we go to the evaluation and improvement of the DR plan. So after the execution, we analyze the test results. We look at our collected data and we check, did everything go as expected? We look at our performance metrics. Did we meet the RTO that we wanted? Did we meet the RPO that we wanted? We look at the system functionality. Did all the critical functions perform as we expected? And we look at the data. Was it complete and consistent? Then after we've analyzed the test results, we communicate to the stakeholders those results. Last, we debrief with the team and we record the lessons learned. It might be that in the test, we detected issues, and those issues could be of different types. There might be technical issues. So, for example, our scripts or our tools didn't perform certain actions correctly, and because of that, the DR test was not successful in some parts. There might also be process inefficiencies. That means that some steps were missing, or some steps need to be changed, or the order of the steps was not optimal. There might also be human issues. So, for example, that some people lack training in performing different steps of the DR test. Then last, there might also be dependency issues. For example, our application was depending on different parts that were not available and that were not expected before. From the DR test, a test report needs to be created where the different steps that were taken need to be recorded. It needs to be recorded by whom was the step done, was it completed successfully or not, when was it started, when was it finished, and were there any issues. And for those issues, we need to identify what they are, what is the type, what are the root causes of those issues, and what are the steps to solving these issues. So after we've recorded the results and the issues and the solutions to those issues, we can go to improving the DR plan. So depending on the different issues that we had, we can either improve our procedure by adding or changing or moving certain steps in our DR procedure, or also changing the order of certain steps in our DR procedure. If we had technological issues, then it might be useful to upgrade certain technologies if the current version of those technologies did not meet the requirements. If there was a lack of training, then we need to implement new training programs to train the team members in performing the different steps that were not completed successfully. And last, we also need to look at the risks. At the beginning, we calculated certain risks and their likelihoods, and then we need to update. Some risks might not be so likely as we thought. Some risks might not have such a big impact as we thought. And we could have also detected new vulnerabilities. So we need to add them to our risk assessment. As time goes on, systems change, our landscape changes. So we need to regularly update our DR procedure so that it meets the new landscapes. And also to see whether our DR procedure is still working, we need to continue testing. So for example, at least once per year, we should do a DR test to check our DR procedure, whether it's working or whether it's not working. We want to talk about the Libelle Business Shadow, which is our disaster recovery tool. It can be used for creating DR environments. So it can be used for creating standby databases, and it also synchronizes the data to that standby database. We call it a warm standby. So it's almost immediately ready to take over in the case of a disaster scenario. And there's different scenarios how we can switch over to that standby database. There's the end of log switchover if the production system is completely unavailable, which might be in the case of a hardware corruption. There's the point-in-time switchover, where we can, based on our time delay that we have set, there we can travel back in time to survive logical errors. For example, if certain data has been deleted, that we can travel to a point in time before that deletion happened. Then we also have the lossless switchover, where we can also take certain data like the online or the redo logs to have minimal data loss, even if the production database is not available. In the Business Shadow GUI, we have the different configurations where we can monitor the state, how the synchronization of the data is going, whether there are issues or not. And with the FS Shadow, we can mirror applications. So there we can set different file paths that we want to mirror to the standby system, also with a time delay. And that allows us to mirror important configuration files or scripts from our applications that we need to switch over our application to a DR site. Then we have some customer stories about DR testing. So for example, one customer, they are doing monthly DR testing. So it's a DR test light. They still have their production system running. And during business hours, they switch over to the standby database and they see that the standby database comes online. They start their SAP application and they access the projects and check that everything is accessible on the DR side. Then we also have a hospital customer where they did a DR test with a hard requirement that the database and the application needed to be switched over within 15 minutes. And there we switched over the database within 5 minutes. Another customer is DR testing one of their central business applications where we switch over the database, the application is switched over, and then application functionality testing is being done to see that projects can be created, that they can be viewed, and that it's all functioning how it should. Another customer is DR testing SAP systems to test their ERP system, that it's available in a DR scenario. And also, we have many recoveries in real disaster scenarios where we have saved our customers from downtime and from data loss. And so as a summary, so we've talked about the importance of DR testing. We've talked about how we can plan the DR test, what challenges can happen there, and also how to execute the DR test. And also it's an ongoing process. So we need to continuously improve our DR test. And last, Libelle Business Shadow is a disaster recovery tool, which can help in automating and simplifying those DR procedures. Thank you for your attention. If you want to talk more about DR testing and the Libelle Business Shadow, please contact us at www.libelle.com.